चलिए दोस्तों शुरू करते हैं without wasting a time. In today video we are going to see how the fragmentation work, okay, and we look for the some few of the interesting things about the fragmentation. So I mentioned the few things about the IP fragmentation. When a router receive a large packet and size of the packet is exceeding the size of outgoing interface, so do the router will break the packet into small pieces or into small fragments, multiple fragments, according to the, and each fragment size will be the equal to the outgoing interface. So here, let's suppose this router XRE1 is trying to send a 9000 byte packet to the XRE4. So once one of the router, as for XRV1 having a two path, one is the XRV2 via one is the XRV3 to reach the XRV4. So on the packet reach, let's suppose packet reach on the XRV2, so XRV2 will check the outgoing interface MTU. Accordingly, it will break the packet into the multiple fragments. Okay. And while router do the fragmentation, it will set the more fragment is the one flag in the IP header. Okay, it will set to one. Okay. And one more thing is only in the initial packet, the packet number one. Let's you are trying to send a data of 9000 byte from XRE1 to XRV2, XRE4, sorry, and packet length is 9000 byte, and let's suppose MTU is 1500. Okay, and this router have divided the packet into a six fragments. Okay, total packet length was the 9000. So to link MTU, we are considering on the outgoing interface of the XRV2 is 1500. So fragment will be total fragment will be, let's suppose, is fragment into the six different parts. Okay. So only in the first packet we will be able to see the initial packet header. So I'm talking about the higher protocol packet header like ICMP, TCP, whatever the thing like we're doing the ping. So header related to the ICMP, things related to the ICMP packet will be available on the first fragment only. Okay. And one more thing is fragmented packet follow one path end to end, and that is required. Let's suppose you have an instead of XRV2 we have a firewall here. Okay, and here we have a router. If router will send the fragmented packet into the different part, in the case let's suppose XRV have sent the one first fragmented packet here on the XRV3, and second fragment packet went to the firewall. Now in the second fragment packet does not have an initial header of the ICMP or TCP or UDP, so simply firewall will break the packet. So in the case of fragmented packet, all the packet will follow the same path end to end. In the case of Cisco, I have seen while taking the Wireshark capture, we will see the same thing in the Wireshark capture also. So let me quickly show you the configuration first XRE1, and then we will proceed for the Wireshark analysis. Here we are on the XRV1, so let's check the first route of the XRV4. Okay, show route 4.4.4.4, and his IP is local 0 IP is 1.1, and we are running OSPF end to end all of the four routers, and we are getting this route via OSPF. And this having a two path, one is the via XRV2, one is the XRV3, and end host is the XRV4. Okay, if I check the interface MTU pair, so here's the interface default MTU. We didn't change any MTU any interface in the network. So interface is 154. So this will be the length of the each fragment 1514. Similar on the other interface also. Let's go to the Wireshark now. Let's do the ping with the, okay. So here we are ping our 4.4 with the help of this loopback source of this router, and size of the packet is 8000 bytes. Let's go to Wireshark capture. I've taken the Wireshark capture on the XRV4 on both of the interface, on this interface, on this interface. So here is the first Wireshark capture file. Okay, here you can see this the ICMP packet which you are doing ping. Okay, so it's a reply, which reply is sending XRV4 towards the router 1. Okay, here you can see in this Wireshark capture we are only seeing a reply only. Okay, that's the reason I was telling you when the fragmentation happen, router follow one path only. So in the one path, so there is no request. The request is available in the another Wireshark capture, another file, which on the down path. So end to end, all the reply packet is following a one path. And here, if you see on the if you select the one packet here, Here you can see in the, if you go to the IPv4 packet, here I am telling more fragment set bit is set. If you expand here, more fragment set bit is set in the case of fragmentation. And 8,000 byte of data we have sent. Okay, here you can see all of the one, two, three, four, five. Five fragments are size of the 154, 1514, in which actual data is you can see in the first packet only. This is the first packet. In the first packet only we have an ICMP header. Okay, as we are doing a ping, so we have an 8 byte of ICMP header. In the all of the packet you will not find the any ICMP header. Here you can, this is here I'm selecting here I'm selecting a second packet. Here you can see we have an Ethernet header, IP header and data only. There is no ICMP header. While in the first packet only we have an ICMP. In rest all of the packets we does not have any ICMP header. Okay, so this is the reason all of the fragmenting packet have to follow the end-to-end one path, because this can create a problem in the case of firewall or IPS in the network, where if firewall will not see the ICMP header, initial header in the packet, it will simply drop the packet. So that's why end-to-end follow the one path is required. And if we see in the first packet, data is 1472, and in the rest of the packet it's 1480. Here also 1480, the next packet also 1480, 1480, and 614. Okay, why in the first packet data is 1472 is the 8 byte we have an ICMP header, and 20 byte is the IP header. 28 plus your 14 byte is this, so total 42 byte header we have in the first packet. So 42 minus 1514 is the our 14, which is 1472 ICMP header. In rest of the packet there is no ICMP header, so we are saying the 8 byte plus 1472 plus 1480 here, 1480 here, 1480 here, 1480 here. And also this is the last fragment of this packet. In this packet we will not see the any fragmentation bit is set. Here you can see this bit is dot more fragment bit is 0, while in all of the packet we have a fragment bit is set. Here also you can see. Okay, so these are the request packet available in other file. Okay, similar here we have in the first packet only we have an ICMP header. Okay, length is 1472, and the rest of packet there is no ICMP, and length is 1480. In the first packet data length is 1472, second, third, fourth, fifth 1480. In the last packet we have a data is 58 by 0, and we does not have any fragment bit is set. So this is the fragmented packet. We have done the ping from the XRE1 to XRE4 with the size of 8,000 byte packet. As we know, Ethernet header size is 14 bytes and IP header is 20 byte and ICMP is 8 byte. In the first packet, we have seen three header: Ethernet header, IP header, and ICMP header, and that's why the data. So total length 1514. Similar way, in the second, third, fourth, fifth packet, we have seen the only Ethernet header and IP header plus 1480 byte data. Total is 1514. And the sixth packet we have seen Ethernet header 14 byte, IP header 20 bytes, and 540 is the actual length of the actual data. So it's in a 614 is showing. If we sum all of this data, like 1472 in the first packet, in the rest of packet, four packet 1480, 1480, 1480, 1480, the last packet 580 plus ICMP 8 byte. If you, so this is the total is 8000.